Hey everybody, welcome to 12.1, the Fundamental Counting Principle and Permutations. So Chapter 12 is going to be all about different types of probability, and today we're going to talk about how to count possibilities for numbers of items, and I'll explain more in just a little bit, but here's in general an example of what we're doing. A deli offers 4 types of meat: ham, turkey, roast beef, pastrami, and 3 types of bread: white, wheat, and rye. How many sandwiches are possible if you choose 1 bread and 1 meat? So what we're going to do is figure out how many different sandwiches could I make. And I'm going to show you what this would look like if I was going to try to do this by hand. You do not have to write this down because I'm going to show you the shortcut in just a little bit. Just want to show you, if I didn't know this shortcut I'm teaching you today, I would have to figure this out by hand. So maybe I would start by writing down, okay, I could have ham, turkey, roast beef, pastrami. Again, you don't have to write this down because this is the longhand way, and we're not gonna use this. You could use it if you forgot the shortcut. But normally I wouldn't recommend it. For each one of the types of meat, I have 3 choices of bread. So I could have ham on white, I could have ham on wheat, I could have ham on rye, and I can do that for each one of my bread types, or meat types, I mean. I could have roast beef on white, I could have roast beef on wheat, I could have roast beef on rye, and basically, once I make this thing, it's called a tree diagram, I would count up how many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, how many things I counted for my last category, and there's 12, so the answer is 12. There is a much faster way of doing it, and it's called using the fundamental counting principle. So this we use if I have different events or different categories that I'm selecting things from. Later we're going to talk about what to do if I have one category that I'm selecting a group from. But here's where we're picking one thing from each of different categories. So here's what we're going to do. We're going to take the number of ways or the number of types in category 1. And let's say that in this case category 1 would be type of meat. So it would be 4. We're going to multiply that by the number of items in category 2. And if I had lots of different categories, I'd just keep going. I would just keep going. The number of things in this group times the number of things in this group times another thing in this group, and so on. Our example then is, my first category is the meat category, and I've got 4 items. My second category is the bread category, and I've got 3 items. And I'm done there because I only have 2 categories. 4 times 3 is 12. That's my answer. Once you know how to do fundamental counting principle, it can make these problems really fast. It does get slightly more difficult. Let's go to example 2. So now I have a standard Minnesota license plate. It's 3 digits followed by 3 letters. My question is, how many different license plates are possible if digits and letters can be repeated? And just so you know, in case you forgot, there are 26 letters in the alphabet from A to Z. And we consider it 10 digits because you may have been thinking 9 because 1, 2, 3, 4, 5, 6, 7, 8, 9. We include 0. So if you include 0, there's 10 digits. In this situation, some of the categories are repeated, but that's okay. It said I'm going to do 6 things because I'm going to do 3 digits times 3 letters. So that means I need 6 blanks total. And so the first 3 blanks are for how many digits I could possibly select. And then my last 3 blanks are how many letters I could possibly select. Alright, and I just told you there's 10 digits. So there's 10 digits in that group, and we're saying that it can be repeated. So it's the same group again. I'm just going to pick again from the same group. So still 10, still 10. And then there's 26 things in the letter group. So 26, 26, 26. And again, I can have repeats, so I have the same number each time for the letters. Now all I do is type that in my calculator. You end up with 17,576,000 license plates, which really isn't that many if you think about the fact that the population of Minnesota is what, 6, 7, 8 million nowadays, and a lot of families, or we have at least one car per person in the state, so we don't actually have that many more possibilities than we have cars in Minnesota. It's kind of interesting. All right, anyways, how many different license plates are possible if digits and letters cannot be repeated? So same situation, I still got 6 blanks because I'm going to have 3 digits and 3 letters, but here's the deal. It cannot be repeated. So the first time I pull from the digits group, I've got 10 digits still. But now, because I've already used 1, I now only have 9 digits left from that digits group. I used 1 of them already. And once I've pulled out that, I now only have 8 left for the second or the third draw. Something similar happens with my letters. So I start out with 26 in the group, 26 letters in the group. I took 1 out, it can't be repeated, so now there's only 25 left for me to pick from. Once I pulled 2 out, there's only 24 left for me to pick from. And when I multiply that in my calculator, I get 11,232,000. All right, make sure as we're going along here, on the side, write down some questions you might have, and then you can ask me in class tomorrow and we can talk about it. All right, let's do example 3. Police use photos of various facial features to help witnesses identify suspects. Wow, struggling with my reading this morning. Okay, one basic ID kit contains 195 hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, and 74 chins or cheeks. The developer says he can produce billions of faces using this kit. Our question is that true? All right, so we want to figure out how many different faces could someone create with these different elements. So if you think about it, I've got the hairline group that I could pick from. I've got the eye group. I've got the nose group, and eyes and eyebrows are in the same group. I've got the mouth group, and then I've got the chin or cheek group. So there's 5 different categories of information they gave us. So it said 195 hairlines, 99 eyes, 89 noses, 105 mouths, 74 chins or cheeks. And I got that just from the information they just gave us. And again, fundamental counting principle, multiply together the number of items in each category. So this is how many items are in the hairline category, how many items are in the eye category, and so on. Anyways, when you multiply that together, you actually do end up with billions because it's 13,349,986,650. So there are billions. Pretty amazing how many different faces there are in the world, though. Everybody's different. Okay, now let's make it a little bit different. Part B, a witness can clearly remember the hairline and eyes and eyebrows. How many different faces can be provided with this info? Okay, so here's what you got to think of. What they're telling us is that for the hairline category and for the eye category, our suspect knows which one to pick. So it's not the fact that, oh, there's 195 it could possibly be. No, he knows or she knows specifically which one it is. So there's only one possibility because they're certain on that. And same thing with eyes. They're certain on which set of eyes it is. So those ones are for sure. So it's just one. And really, you wouldn't even need to write those down. But I am, so you can kind of see what's going on here. Then the suspect doesn't know this other stuff, or the witness, I mean. So there's 89 noses, 105 mouths, 74 like before. Those are the categories they don't know, so we still have to pick from all of those. Multiply those together, and there's 691,530 faces. So it actually cuts it down quite a bit, but there's still thousands and thousands and thousands of faces for the witness to try to identify. Once again, write down any questions you have. Now we're going to move on to something called factorials and permutations. So first of all, sometimes when you're doing this fundamental counting principle, you might get into a situation where I have something like, for example, 10 times 9 times 8 times 7 times 6 all the way down to 1. And instead of typing that all into our calculator, there's a shortcut button, and it's something called a factorial. So right now, this is just a math fact I'm about to teach you. Just a math fact, a math operation you need to know how to use. So what a factorial is you multiply a number by itself and every number below it down to 1. So for example, and by the way, the factorial symbol is an exclamation mark. So this doesn't mean 6. It means 6 factorial. That was one of my best math jokes, in case you're wondering. Okay, so 6 factorial, that's how you read it. And it's kind of like, for example, we have a symbol for square root. You know what I mean? We have a symbol for squaring something. I mean, this is just another math number operation. So this operation of factorial means that I need to do 6 times 5 times 4 times 3 times 2 times 1. And I want to tell you that on your calculators, on your calculator, and I don't know if this program I'm using can handle this calculator, so we'll see what happens here. To find the factorial button, you're going to hit Math, so the Math key right under Alpha. You're going to scroll over until you're at PRB. It stands for probability. So again, this is our probability chapter. All this stuff is under the probability section, and you select number 4. Now I have a problem here, and that is I have not yet typed in my number. So before you select that, you're going to want to type in the 6 so that you do 6 and then the factorial. So see, that's not going to work for me. Okay, so I'm going to go back to 6, then the factorial, and the answer is 720. Now alternatively, I could have just typed this all in, and it's really not that bad for this one. Once you get up to ones that are 12 factorial or 13 factorial or something like that, it is very laborious to have to type them all in. So you can use the factorial button. Just another example in case you're not really sure what we're doing yet. Only write this down if you need to. For example, 4 factorial would be 4 times 3 times 2 times 1. So you just take the number itself and everything below it. In official math language, here's what the formula looks like. It is n factorial equals n, so that's our number, and then the number that's 1 below n, the number that's 2 below, and so on. So if you see that in the book, that's the mathematical way of saying what I just taught you. And then here's one definition that you need to know and memorize. 0 factorial is defined as 1. 0 factorial is defined as 1. Very similar to how we have some of these other rules, right? Anything to the 0 power is equal to 1. For a different reason, but a similar property, so maybe that might help you memorize it. I'm going to stop there and talk about permutations in the second part of the 12.1 video. Thanks for watching.